Hi, my name's Alan Joyce. I'm the Director of Content Development for Wolfram Alpha, and today I'm going to be talking about geographic entities in the Wolfram language. Um, a few things that I want to make clear up front. There are a few things I want to be sure people understand what this is not. There are some other talks in this series that are going to cover some closely related areas. Um, Among these are geographic visualization. So certainly there are going to be some examples today that make use of geographic visualization functions, but this is not a talk specifically about that functionality. There's obviously a huge amount of other geodetic data and computation that's possible in the Wolfram language. Again, some of these functions will pop up, but this is not a talk primarily about the functions in the language about these things. And also there are a couple of other talks, some of which I'll be giving over the next couple of months that focus on some things that are data associated with entities that are primarily geographic entities. But this is not going to go too deeply into that data because we want to focus on the data itself in another talk. So socioeconomic and demographic data, some other information about more historical entities, which includes historical countries and military conflicts. Those are things that will be covered a little more deeply in some future talks. So what I do want to cover today is a little bit for people who aren't that familiar with it, very briefly, just going through basic entities and entity usage in the Wolfram language, a little bit of talk about some related functions that are of particular value when you're working with geographic entities, and then walking through some examples that we featured with the release of version 12. So this was a page that was focusing primarily on geographic entities, and here we were looking at kind of physical geography, structures, and then hydrological features and some related entities there. And that's sort of how I've broken things down here today. So for people who aren't that familiar with entities, there are hundreds of different entity types that are represented in the Wolfram language, um, representing millions of different entities and thousands of properties across all of them. Something that was new, even though many of these entity types already existed, something that was a new feature in version 12 is that now each of these types has its own entity reference page. So this is a much more convenient way for people who aren't familiar with these to get in, get some samples of the types of entities, descriptions of what the nature of the entities are, what the scope of that domain is, some sample entity classes, overview of properties, and then lots of examples that are give you a good sense of how to interact with entities, the kinds of data you can pull out, and some of the more interesting things that you can do with that data when you've got access to it in the Wolfram language. Um, the actual entity framework itself, there's a whole suite of functions that can be used to interact with entities, from discovering them, looking them up, filtering and sorting and aggregating them and doing all kinds of things. Again, I'm not going to go deeply into the behavior of all these functions, but these are things that are useful for anybody who's working with any types of entities. Uh, Also, there's a helpful reference page just focused on geographic data and entities. So again, here this is pulling together some of the most useful geographic functions, both for finding and working with locations, doing some visualization, and also just an overview of some of the primary geographic entity types. Many of these I'll just be kind of skimming through today in this talk. So just getting started, there's some links here to those things that I was talking about. Working with entities in the language, sort of the easiest way to um, find an entity, start working with entities is you just there's one. You just type control equals in a cell, you get a natural language input box. You can type in the name of something that should be an entity, and that gets converted into the canonical representation of that entity in the Wolfram language. Uh, if that's the right thing you were looking for, then you can accept that interpretation, you hover over it, and you can see that this is an object that's an entity, it's of type building, and then it has a unique canonical name. And this is a camel-cased Empire State Building, : and some random string that would help to disambiguate that from if we had some other Empire State building entity, just so that each of those things is unique in the database. You can get random entities of any type. You can specify a number and just get a random setback. You can get a full list of entities in a given domain. Uh, you can get entity counts and see what those are. When you're working with single entities, the easiest way to interact with them here is once you've got one, this curried form, just the string form of a property name, you can evaluate that and get a value. You can get multiple properties at one time. You can get multiple properties and say that you want those in some particular structured form, like a property association. So you get the left-hand side is the name of the properties, the right-hand side is the values. Um, you can get all of the data associated with a particular entity back in a big chunk. So property association again, you've got an association, left-hand side is the properties, and here these are the canonical full entity property forms. Um, these are, you can represent these as strings just for convenience when you're writing code, but these actually exist as things that are an entity property of type building, and then there's a canonical name for the property itself. So you've got all that data. When I'm working with these, I often like to get data sets back. It's just sometimes a nicer way of looking at a lot of data altogether. It's a nice formatted block. You can page through properties when you've got a lot of them. So it's just nice to work with things that way. And again, even with these more structured blobs of data, you can do the same thing with as many entities as you care to feed into it and get comparisons, and then you can start digging into and cutting into that data in different ways. There is also, a lot of people don't know about this. I'm surprised always the number of questions we get. How do I find out where the data comes from? Most properties, it depends on the domain. There are many domains where the data is stuff that we have really curated in-house from a number of different sources. There are others that are coming from, maybe primarily from some crowdsourced external sources. There's data that's licensed from specific providers. But if you've got a specific property, just the source property of that property will give you some metadata about the source or sources used to populate that property. In some domains also, this is not necessarily that prevalent in geographic entities because most of the properties are fairly obvious and common types of things. But there are some things that are a little technical, might not be familiar to people who don't deal with that kind of data or that domain a lot. And again, within the language, you can ask for the definition of a property and get that data out. And this can be useful when you're creating visualizations and charts and tables or any kind of material. Just have access to those definitions directly in language can be helpful. That was mostly working with individual entities. There are also a few different ways that classes of entities show up. So again, control equals in something like Appalachian Mountains, you get this Appalachian Mountains entity class. And this is sort of one particular flavor of entity class where it's a named class. This is entity class of type mountain, and there's a canonical name for that class, and it's Appalachian Mountains. And again, with these, you can see if I got the property right. You can get all the data for that for all the members of that class. You could say, because this doesn't really make it clear what you're looking at, you can ask for an entity association, and then you just get out all the individual names, all the values associated with whatever property or properties you ask for. There's another type of entity class which we call it's more of an implicit entity class. So you can specify this as an entity class, pick a geographic type like building, some structure. And then you can say, I want to only get, this is going to be a class whose members are buildings that meet these criteria. Buildings where the architect includes Frank Lloyd Wright and the city location includes New York City. And then that will find all the entities that we know about that meet those criteria. Like I mentioned before, there are a lot of other functions related to entities that were new in version 12. There are a bunch of entity class specific functions: filtered entity class, sorted entity class, aggregated, and you can use these to do some fairly sophisticated lookup and filtering and sorting and computation on classes of entities. So here you can write any arbitrary entity function and find all the mountains here where the elevation is greater than 5 kilometers, and they are also on the continent of Africa. Um, I mentioned that there are obviously lots of other uh, geographic location and visualization functions. I don't want to spend a lot of time talking about these. They're very powerful, very deep, lots of options, lots of things you can do. But the point I do want to make is any set of entities, any entity or entity class can just work natively with those functions. So, if you've got the Himalayas, something like GeoListPlot, you can just feed that entity class into that function, and it'll know that you want to find the locations of all the members of that entity class, and you're going to plot those on a map. Uh, here, using a GeoNearest function, this is saying I want to find all the volcanoes within 100 miles of Seattle. And then you can take that list, you could feed that into something like GeoRegion Value Plot and get a nice choropleth map where you're taking the points of those volcanoes are colored according to their elevation. So there's a lot of really powerful things that you can do without needing to explicitly request data, without necessarily having to understand what the structure of that data is. You know the entity or entities you're working with, you know the function, you know the kind of visualization you want to make. It's really easy to generate those. And also just outside of sort of geo-specific functions, things like sunset or weather data. Want the sunset at the location of a particular geographic entity, you can just use that entity. Weather data, same kind of thing. Get the temperature at a particular location. You can start combining things. You've got an entity class here. I want all the buildings in Chicago whose height is greater than 1,000 feet. And I want to generate a plot of the construction end dates of all those entities. And that just automatically works. It looks really nice. Um, Wikipedia data is another really useful thing. And this is something that, sorry, 1 second. Something that's really useful that we've been trying to expand our alignment between entities and Wikipedia, Wikidata, other sorts of external sources. So you can take a function like Wikipedia data, just feed in an entity and get out the full text of that article through the Wiki API, get summaries, extract all the images from an article. So again, kind of useful to have access to lots of other textual and other data when you're working with particular entities. Again, so then what I wanted to do next is just kind of go through more specifically some of the examples that we were highlighting as part of version 12. So again, we have, 1 second. Physical geography, looking at volcanoes, and I was pointing out mountains above, and we've got, in many cases, there are volcano entities that also exist as mountains, but the volcano entity has some, obviously, volcano-specific properties associated with them. So for volcanoes, you can, for example, get the last known eruption date of a particular entity or a set of entities. And then we could do something like take a filtered entity class. We can write a function. We're going to find volcanoes where the last known eruption was within the last 5 years. We can get out to me, surprisingly large list of volcanoes there that meet that criteria. And then we can write a little bit of code here that takes that, and we'll take any arbitrary list of countries and generate a nice plot that shows where all the volcanoes are that have erupted in some span of time. So for this example was all of the volcanoes in countries that are in the ring of fire that have erupted in the last 25 years. Mountains, again, some of these are volcanoes, some of them are not, but mountains have a lot of interesting and useful data. This ranges from the obvious sort of positions, coordinates, some elevation, things about prominence and isolation of the peak, and then also links to the entity classes that they're part of, ranges and subranges. When a particular peak is, has a parent peak, links to the other associated mountain entities that they're connected to. And also just some other textual information, some categorical things about climbing difficulty, typical months when they're climbed. So a lot of things that you can work with in different ways. You could do things here. I mean, this was just an example where we were taking, using geo entities, find all the mountains that are in a particular area, in this case, California, get the prominence for those, and just render that as an entity association. It's just looking at the top 10 of those here. You can retrieve a range of data for those things and start building a data set that has some of the things you might be interested in just for that entity type. Coordinates, names, get an image of most entities, elevation, prominence, a little bit about climbing difficulty. And then you can go from there and produce a nice map where you're saying, let's take all those mountains. We want to show them on a map. And we want to have some indication of the isolation of each of those peaks represented by a geodisk around the entity. There's a lot of data for mountains, a lot of data available for many entities. There are some that are not super deep in terms of the data that they have associated with them. Beaches are a good example here. Beaches, there's not a lot that we have to say about beaches in the knowledge base except what its name is, countries it's associated with, and position data. One thing that is kind of interesting there and obviously relevant to beaches is a UV index value. And this is a dynamic value. You ask for this, and it's fetching this the same way that weather data gets temperature or wind speed or anything else. So I think if I generate this now, because it's the middle of the day in Illinois, there's not too much UV risk in South Melbourne Beach right now. This I evaluated at a different time when it would have been daylight there. But you can do things like, again, let's build an entity class of beaches in Australia, give me the current UV index and entity association for those, and then basically just feed that into GeoRegion value plot. And you get something that's a nice view of relative UV intensity around the whole country at a particular point in time. A little bit of extra code. You can also dig a little bit deeper down. Let's say get all the beaches within a particular radius of a city. Write a function that just converts those to UV index values to a color, and then you can make a plot for a smaller region. Use icon data here too to show beach icons, color coded according to the current UV exposure level. Structures, obviously a lot of other kinds of interesting data available for man-made geographic entities than we have for natural ones. So, for a building, for example, you can dig in here and we've got links out to, we've got date-related properties, construction, completion dates, groundbreaking dates in some cases, physical characteristics of buildings, everything from floors, floor area, heights, different kinds of heights in many cases. Architectural versus a total height for buildings is relevant. In many cases, construction costs, and also in a lot of cases, links out to specific people data entities. So there are a lot of different ways here that you can start finding and analyzing building and other geographic entities where we're able to filter things by creators, we can filter things by time periods, we can filter things by quantities of money or counts of floors or sizes measured in different ways. There's kind of an interesting visualization somebody did here. There's lots of different ways you can measure height for particular entities. Here we can, let's see, we can take, well, there's 3 different height values. This is just filtering the list of properties of buildings. There's an architectural height, a total height, a roof height. Here we're taking all the buildings within 2 miles of One World Trade Center. And again, this is just a list of entities. Feed that into GeoListPlot and get a nice visualization of where they all are. From that, we can fetch the heights for each of those things, take the maximum value of whatever heights are available out of this list of height properties. And again, a little bit of code I'm not going to go into too deeply here, but some of this is just kind of generating textures and producing things to make what's kind of a neat 3D map. Given that we have the heights, we have the positions, we've got street maps. You can generate a pretty cool 3D map that shows the relative heights of all those buildings, plotted on a street map, and you can move that around and zoom in and out. Uh, Other things that are, sometimes super useful, sometimes just kind of fun. We have a lot of data that we've curated on amusement parks and amusement park rides. Uh, Depending on the type of ride, obviously this is not going to be super useful for a haunted house, but for roller coasters, there often we have some things like the maximum drop, vertical angles, maximum G forces on the ride, maximum speed. Um, and also the parks that they're associated with, in some cases the people who designed or created them. A lot of interesting data there, but you can dig in here. You could find all of the rides associated with a particular park or set of parks, pull out some of the quantitative properties of those things, and kind of get an interesting picture of some of the major rides at different important parks. um, I don't know if you want to find things that your kids can ride on with you, or maybe find things that your kids would be too terrified to ride on. This could be a useful view. Um, Bridges, another interesting structural entity type. Um, Again, data about designers, physical dimensions, also a lot of date-related properties, including collapse dates. Not populated for every bridge, thank goodness, but some do have that property populated, and that can be an interesting way of digging into these. This is just an example of going in and taking all the bridges, for example, in a particular city. Let's find the opening date of those, get an entity association. Again, this is just left-hand side is entities, right-hand side are data objects. And then we can, again, produce a quick plot that shows us the relative age of all the bridges that are along the rivers here in Pittsburgh. Stadiums, another useful entity type here. And here's a case where I'm using filtered entity class. These are, when you've got entity class with this syntax, um, a lot of times what's happening here is you're just doing sort of a very basic um, match or filtering on particular property values. But you can do more complicated things here um, when you're writing your own entity functions and feeding them in. So here we're saying, let's get all the stadiums where the owner property, any of the members of the owner property contains one of the members of the universities in the Big Ten Conference. So we get a nice long list of entities there, all these stadiums. And then we can go in here, we can retrieve things like construction cost and maximum capacity for each of those. Make sure we've find all the cases where we've actually got a quantity for each of them, and there isn't missing data. So then we've got this association that's left-hand side is the stadiums, right-hand side is cost and capacity. And then you can just feed those directly into listplot. Listplot knows to where it can do some callouts for the entities, and you can get a nice view of some of this data for stadiums. The last cluster of entities I was going to touch on, some of these hydrological entities. Oceans and seas, first and largest among them. We've got a lot of data about these. And despite the name, an ocean it's not just things with ocean in their name, it is also other major seas. Actually, it's things that are defined. I'm gonna fail to do this. Let me look for it. Is things that are, we don't have the description here. These are things that are defined in a particular document by the International Hydrological Association. And there are very specific definitions for the extent and boundaries and borders of all these different entity types. So you can kind of see there. not just Atlantic, Pacific, Indian. We have lots of other seas and data about all of those. So areas, depths, other bordering bodies of water and countries, data on coastlines, some computed properties. So you can sort of filter bodies of water by maximum northwest or east-west extent, and polygons for a lot of these. And so that combined with some of the geographic visualization functionality in the language. Here we can just say, I want to get the polygon for the Atlantic Ocean, and I want to see that styled as a relief map, just overlaid on the regular world map. Um, so kind of interesting with oceans and seas, you get some of that bathymetric data, and it's interesting to be able to dig down into that. Uh, River entities, lots of properties of rivers, things about origins and drainage areas, discharge points, outflow and source coordinates. So we can do some things like, let's take all the rivers that we know of that flow into the Mississippi River, find all of those. Then we can even extend into different geographic entity types. So let's say bridges. I want to find all the bridges where we've got a position, and we will find bridges who cross any of those rivers that are in that class we just created. So this is this set of rivers. Here we're going to find any bridges that cross any of those rivers. And then we can just take that and again feed it into GeoRegion value plot, and taking the length of those bridges. And kind of interesting here, just playing around with it to see uh, relatively short bridges as we're further up here, and as all these start to merge into the Mississippi and we get further down here, we see many more wider and wider and wider bridges going down to the Gulf. um, Shipwrecks and undersea features, two separate entity types, but kind of interesting ones to look at together. um, and this was kind of an interesting example. Let's take all the seas in the Mediterranean and associated next to the adjacent to the Mediterranean Sea. Uh, we can take a look at this is that collection of seas here highlighted in light blue. Uh, get all the shipwrecks that are in that geo group of seas. We've defined this collection of entities as a particular geo group. That gives us 173 shipwrecks, pretty large. We can take a random sample of that set. We've got a whole bunch of different things here. Again, you could go into any one of these entities um, and pull out whatever all the data is that we know about that given entity. Some of these they are a little morbid, but for some of the more notable shipwrecks in history, there's detailed data even down to passenger counts and number of casualties and when they sank. Uh, we can plot all those individual shipwrecks on a relief map. We can dig in here and get the elevations for all of those and kind of see where we've got the kind of peaks and depths here. Um, we can also look at undersea features, and these are things like trenches and mounds and other kinds of things that show up undersea. There really wasn't any clear correlation here, but just kind of interesting to see the density of these entities everywhere. There really are a lot of features under the water, at least as many as there are above water in some of these places. Dams, kind of my final example here. Lots of data here, not just about positions, but in this case, uh, many of these entities are used for generating hydroelectricity. And so we've got data on annual power generation. In many cases, this is also a time series going back. We've got information on generation capacity, when the power plant was commissioned. Um, Lots of interesting quantitative data that you can use, types you can use to filter dams. And this was just an example. We're taking all the dams in the U.S. that have power generation and location data, um, finding the top 10 there, just taking the largest by the last value we extracted here, which is annual power generation, and then taking that list and feed them into GeoList plot, just seeing where the top 10 energy producing dams are in the U.S. That's most of what I wanted to cover here. Nobody's feeding me any questions, so I'm not sure if there are any. But again, I think there will be some other talks coming up in the future that focus on some of the things adjacent to these entities. So the actual visualization functions, some of the other functions for computing with geographic information, and then some of the other entities that are geographic in nature, but where the data and the most interesting uses of the data is not necessarily purely geographic. So we'll have some future talks about that. Uh, for reference, there's lots of really good information on working with entities, all these functions in the Wolfram Language Documentation Center on just knowledge representation, uh, lists of the entities grouped by different categories. Um, but I think that's all I wanted to cover today. For anybody who's interested, the next talk in this series, I believe, is next Tuesday, September 24th, also at noon, and that's going to focus on food and nutrition data in the Wolfram language. All right, thanks very much.